Our next speaker is Arun Shukla. He is a data science developer at Atlantic International Research Center, working with Julia scientific machine learning and SAR-based Earth observation. His research spans hybrid SAR optical classification, post-fire impact assessment, burn severity mapping, and the study of forest fire dynamics across regions such as Mizoram and the Indo-Burma biodiversity hotspot. He also works on machine learning approaches for environmental monitoring, land use, land cover analysis, and Earth observation data processing. His scientific contributions appear in journals such as Earth and Space Science, Remote Sensing Applications, Environmental Science, and Pollution Research and AGU Proceedings. Arun.
Just checking the HDMI connection to see if everyone can see your presentation even online. Yeah, there we go. It's already. It already was. Yeah, there we go.
Good morning, everyone. Happy New Year to all of you. Thanks, Adriana, for that insightful look into the ocean internal waves and their importance in climate science and marine navigation. You have beautifully set up the stage for why detecting these waves matter and why doing it efficiently is a challenge we can tackle together. My name is Arun Shukla. I am a data science developer here at the Atlantic International Research Center, Azores, Portugal. And I am here to bridge that scientific head with a computational opportunity, which is disguised as a challenge, you can say. We have a working Julia pipeline currently that already detects these hidden waves from the satellite imagery. But like any other real world tool, still there is a lot there in which we can improve, optimize, and means the hackathon is not about starting from zero. It's about taking what works already currently and optimizing it together, whether you are here to sharpen your Julia skills or means explore GPU ready to turn ocean science into a high performance code. Let's begin this journey means for the next 5 days. So our objectives is very clear. The core objective is to improve the current hybrid Python Julia pipeline into a high performance GPU accelerated pure Julia implementation or a means maximum Julia and minimal Python use thing. That would be the main goal. Next is for the goals are quite the goals which we are having, it is to improve the AUC ROC from 0.89 to 0.95. Then we need to reduce the execution time, which is currently around 1 hour to somewhat under 10 minutes. That would be good. In fact, better quite. Then add GPU acceleration for the complete pipeline. The next is desirable, but this is the place where the opportunity lies, where the greater challenge or collaboration things can go, is to eliminate or minimize the Python dependency, which is currently there. Now let's see what the data sets which we are working with. We have nearly a large collage of around 20,000 images of ocean internal waves, which we have, these are the SAR images, which we have downloaded from Sentinel-1 WV mode satellite images. These were a total of 19,521 images. Out of this, around 70%, that is 13,668 images, these are meant for training. The remaining 30%, that is about 5,860 images that are there for testing. Importantly, here means 50% of the images in the training and testing both, they are positive. Positive means those images are showing internal waves, and the remaining 50%, they are negative, means those are there, means which seems that internal waves are there, but it's not. These are of 224 by 224 resolution in RGB format. Processing requirements are very clear and obvious also, to means we are having PNG images. All these are PNG images from which we will be doing feature extraction. Then we will be using XGBoost type of ML algorithms for classification, and finally the prediction will be happening. Last is you are having a means link for downloading the data set from here, which will be means it's in zip format, so it will be easy for everybody to download. Now let's have the overview of what we are currently at. Means overview of the whole machine learning architecture thing. Means currently where I stand with this whole pipeline. We have used in this EVA 02, which is further using the VIT transformer, which is the current state-of-art approach for image recognition. We then use ONNX runtime for fast GPU accelerated feature extraction, and an XGBoost classifier to make the final wave detection, achieving an impressive accuracy of around 99.9%, whereas the AUC ROC was still a quite bit low. It was 0.89. And then and yes, there are still limitations to what I have done till now. Means the feature extraction thing takes around 45 minutes, and rest the other thing, predictions and other thing, it takes around 15 minutes. So overall the whole pipeline takes 1 hour to finally detect the images. But this is exactly where means the hackathon work which we will be doing for next 4 days comes into picture. Means we are here collaboratively, we will collaborate, we will work as a team in order to optimize, accelerate and refine this pipeline to be faster, leaner and even more accurate. I'm just going a bit detail into the existing pipeline so that it may be a bit easier for most of you to start with the thing from today onwards itself. Means in the existing pipeline, there are 4 main components. The very first thing we will be extracting features. We will be extracting features. Before this, means already I have uploaded the model. Means you are having the model in the repo itself in the data part. Otherwise, means the very first thing which we need to do is to import the vision transformer using Python code to an ONNX file, and then using that ONNX again means Julia code will be able to access it and extract features. And in that only means we have incorporated the GPU CPU's switching. It's still, here is the thing where again we can work to optimize it to make it a complete GPU thing. This feature extraction extracts 1000 feature per image. That means one single image is being represented as a vector having 1000 components. Means a 1000 tuple, you can say. Next is the data alignment. Means this you will get more detail when you will be running the code. You will understand. But still, there were issue which rose in the way I approached the problem. was that means the testing and training data, they are having one serial numbers, you can say. In fact, they are not serial also, means they are just numbered. And when we train when we do feature extraction, then what number is given by the machine, that was different. So in order to match both things, I need to do this thing. There was a means ID mismatch thing, and for this I created a mapping between the two, and it went well. But still, it took a lot of time for me. There could be a different approach, for, especially here. Then comes the model training. Once these things are done, then XGBoost comes into picture, which I have used with GPU support for model training, and for which the means train_final.jl is the link, is the code, script code, which is there in the repo itself. Then is the prediction thing has been made using the predict.jl, means again this is there in the repo. Means now here means this prediction.jl, it's doing the prediction and is giving the final result in terms of CSV, which we want in the hackathon also to as a submission. Then next, where currently in terms of performance, where currently this whole pipeline, what I have done, it stands, where means it's AUC ROC is coming a bit low, it's 0.89. We have done 5-fold certified validation in order to see that it generalizes well and validates the thing properly. Strong regularization has been tried to apply. I tried to apply strong regularization things. Prediction 100% wave classification was done, but slight data imbalance issue means right now is occurring, means that needs to be improved. Then computational performance means it's taking 1 hour, around 1 hour, means it's switching between GPU and CPU, and it's totally taking 1 hour right now on my machine. Training takes around 42 minutes. Inference and all other things, it takes around 15 minutes. Total memory which is being utilized is 12 GB in the peak usage time. Known issues means one issue was the ID mismatch thing that I have dealt to means almost done. Then data imbalance that needs to be optimized more. Then GPU acceleration that is also partially implemented, that also needs improvement. Then pipeline could be more overall, means this pipeline needs to be improved. Now comes the problem, means for the hackathon thing, means till now this was where we stand today right now. The problem is means classify the satellite images, internal waves, detect the ocean internal wave pattern from the means imagery. Why already my senior Adriana has dealt with it. Then the data set already we have talked about. It is in PNG format, and feature extraction means 1000 dimensional feature vector extraction is happening. Current performance is the AUC is of around 0.8905, and runtime overall it's taking around 1 hour. So the challenge here is that you may all, I would request most of you that take some time and start working with the code and try to make it better in whichever field you specialize, in whatever way you feel it right. Again, here is the means my code repo link, the very first thing. From there you can access it. And the repository structure is almost very clear, and how to the sequence in which all the files has to be executed in this means is already given in the README thing. From there it can be taken, and means data this repository structure is quite clear and obvious. Now the thing that where the opportunity means lies, means everyone can take his or her own share, means wherever he or she specializes. the very first thing is the model accuracy. We need to improve it, the AUC ROC from 0.89 to 0 point something greater than 0.95 or 98. That would be, if greater than 98, it would be excellent. Greater than 95, quite good, very good. Then means what approaches we can have, means what I think, means the very first thing, the way I went, means I think we need to address class imbalance in a very better way. Then better feature extraction using parallel programming or GPU thing can go. Ensemble methods can be used. Then for performance optimization, we need to reduce the total runtime from 1 hour to something less than 10 minutes. Then approaches here, we can go for better GPU utilization, parallel processing, and other optimized batch processing things. Technical stacks and constraints means what you can use is Julia, of course. My current code is already there. Then available things mean GPU access. Then ONX model, again it is in the data. XGBoost.gl for classification. Full data set is again given in the repo, the links, and even in the this PPT also it's given, and the PPT is also available in the repo itself. Then constraints are there that the constraint which we have is very few, means must maintain computation submission format, means the final submissions should be in the form of some CSV file, need reproducible results, should be available to run on standard hardware. Evaluation, you may say, means it's based, the very important thing is the AUC ROC improvement, then is the runtime reduction and the code quality. Hackathon structure means today means can be utilized for introduction and setup things, understanding my pipeline, how I went, then the initial baseline, whatever codes have been shared, you can run and use. From tomorrow till Thursday means we can go in teamwork for optimization. If some mentor support means many different technocrats are here, so we can have them. Then progress check-in, again, anytime means we can discuss in coffee breaks and other things. On Friday, finally, again, I will be here, and around we will be having a session of around 1.5 hours, in which we will be having 10 minutes presentation. Then means live code demonstrations will be happening, and some technical discussions will be happening that how the things have been improved. Submission requirement, again, that optimized code, performance metrics, AUC runtime, brief presentation, document of improvements and all. Learning outcome at the end means the technical skill, of course, Julia ML pipeline, optimization, GPU acceleration techniques. We will be having handling real world data challenges, production, ML engineering. Research skill will be enhanced, means debugging complex ML pipelines, performance benchmarking, experiment design and validation, documentation and presentation. Then community benefits, means it's a win-win situation for all, means for us, each one of us. We will be learning from means what I implemented, share improvement with each one of us, build networks and collaborators with Julia ML practitioners, contribute to open source ML in Julia, and final goal, everyone leaves with better Julia ML skills and potentially publishable optimization techniques might be. Thank you, everyone. This is my email ID, means you can contact me on this also, and thanks a lot. Means floor is open for the questions, means if you have any.
What is the repository name? Like, where can we find the repository?
Pardon?
I probably didn't catch it, but did you show the repository name?
The S3 that you add in your. No, I think it's the data.
Okay, it's there. Okay. Thank you, I didn't catch it.
And there's a link for the data too.
Arun, can you show the link to the data set? There on the bottom, there's the link to the data set.
I was wondering, how do you get the features? What neural network do you apply to get the features? Maybe I missed it. This 1,000 features that you get from the images.
For that, we are using the VIT transformer. First, we are importing it on an ONNX file. Then that ONNX file, that file is means accessible by Julia also. So now using Julia, we are doing the feature extraction. That in feature extraction, each image that is encapsulated in terms of 1,000 dimensional vector. Means each.
The VIT transformer, on what data was it trained?
Means it is in Python.
No, on what data was it trained? What data did you use to train the VIT model?
For training, we use this data only. For training, we use this. For training, VIT is trained on I think 30 million. I need to check exactly. Means it's trained on 30 million images. What for this particular project, we use this 20,000 SAR images in PNG format. This has been used to train it finally.
Okay, so the VIT model was also trained on internal wave images. It's not a pre-trained model from
No, it's a pre-trained model. It's a pre-trained model. VIT is a pre-trained model.
Yeah, but it was pre-trained. It was trained on the actual data, not on something else, not on another database. It was really trained on. No, it was not trained. Okay, but on what was it trained?
It's a pre-trained transformer. It was trained on 30 million different types of images.
Oh, so ImageNet or something? Yeah, so ImageNet probably something. Okay, that was my question actually. And actually, I'm wondering, why do you use first? Why do you not train the VIT directly on these kind of images, and let the VIT model do the classification? Why do we have two things? So the VIT and then XGBoost. Why don't we have just a neural network doing the classification?
Because we are not having such a high performance pre-trained transformer made in Julia, completely in Julia. That's a big, that's the real world current thing where innovation can go in, where innovation and collaboration, and it's the biggest challenge, to make a fully complete Julia pipeline for this thing. The very start is with the use of Python code itself.
Okay, thank you.
I have another question. So why are you using the RGB format? I mean, is it because to fit in with the existing tools? Because it looks like the SAR only have one polarization, which means it only have like one channel. So it could be like a grayscale image. I mean, it doesn't look to me like there's any colors in the image.
It's required. Otherwise, it was a we have converted in here the image is in RGB format, but when we are using it in the code, we have converted this RGB into a it's another channel alpha we have introduced in it which is encapsulating the transparent pixels, and we are making it RGBA format. In the code itself, we are converting this RGB format data into RGBA format thing inside the code.
I guess it's the same thing. It's because it was using a pre-trained model that was pre-trained on colored image. Therefore, you have to use your RGB.
Yes.
Yeah, because I mean the data fundamentally is not in RGBA format. I mean, I think the data itself could be expressed as like one channel data, like with one band, just as a grayscale. I mean, that would reduce data by a factor of 3 or 4. I mean, unless you have any differences between the three, like the red, green, and blue colors arrays, or if it just stores the same values 3 times.
No.
Okay.
Yes.
Thanks, Alexander and Simon. So there is the reason to launch this now is several-fold, but there is great opportunity for improvement right now. And one of the reasons we first trained the model with the images. We had 400 images. We had, I think, 400 positives with augmentation multiplied by 4 approximately. So there wasn't a lot, and that's why using a pre-trained model, generic model, increased the performance by a lot. So from 60 to 80 or something like that. But now, so we kept working throughout the year. We kept the system running, and now we have, I think, 10,000 positives. No, 2,500 positives. So that we can augment to around 10. And so we have a much broader base now to train. Maybe if you go to direct training instead of using a pre-trained model, we can get better performance now. But it wasn't the case in the beginning. So what Arun has been doing for the last months, Arun just joined our center recently, and this time I wasn't so kind. Normally I let people use their stacks, but Arun, I told him, you have to use Julia. I think it's safe to say that here. What he's been mostly doing is converting our existing data pipeline to Julia. She's not probably the best, which was developed in Python. So it's probably not the best approach, but the goal was to have a good starting point for you guys to help to chip in with ideas like those, which we can now go back and rethink the whole thing. And that's exactly what we like to do. Thanks. And we really appreciate your help. But we're giving you a much larger data set to start with than the one we had in the beginning.
Yeah, the hackathon is open to you all, and I would humbly request each one of you to please at least give your level best, a decent try to certain levels. Also, it would be good. Means if we all will. If we all will give our best, then certainly in next 5 days, we will come out with some very good outputs. And I will be available all the time, will be here and there only. And in coffee breaks, certainly we can discuss more about this thing. Thanks a lot. Thanks everybody for patience hearing.